And we're live. Hey, everyone. Thank you so much for joining us for this week for On.NET Live. I'm your host. My name is Cecil Phillip. And today we're going to be talking about some cloud native patterns that you can start implementing in your applications today. And I have my friend Nish here who's going to talk to us about it. So Nish, why don't you just introduce yourself to the folks a little bit, let them know who you are and what do you do?
Yeah, absolutely. My name is Nish. I work on the .NET community team, and we focus on doing a lot of community stuff. And I specifically focus on the architectural guides and reference samples. I kind of like put itself as helping developers build production-ready apps with .NET. So it's one of my favorite areas, cloud native and microservices, and we are doing the microservices one. So I'm super, super excited to be doing a lot more in-depth talks on microservices and other things.
Awesome. And I know this is Microservices March here on .NET Live TV. We know that you, Nish, in talking about those architectural guides, I know you work on a lot of those, cloud native guides, the containerization guides, and so on and so forth, right?
Yes, absolutely. Yeah. So there is a bunch of guidances out there, and that is specifically focusing on two things. One, if you're just getting started with microservices and cloud native apps and other things, we have some great guidances to help you go through that. Last week, we announced the Dapper for .NET developers, which is also a great application runtime that you want to take a look at it if you're getting started with microservices. There is also other guidances, like, if you are someone who's coming from the .NET framework side of things, you want to actually modernizing things, and you're looking at Docker, Kubernetes, and all kind of things, and you're saying, how do I modernize things? You want to have a step-by-step approach. So there are some great guidances and reference samples out there to help you go through the journey.
Awesome. Well, hey, I'm definitely excited to kind of dive into it. Just want to acknowledge the chat really quickly. Looks like we have some folks joining us from Poland, from Turkey. Hey, I know it's probably really late where you folks are, so thank you so much for joining us. Really hope that you're going to enjoy some of the great demos and content that Nish has prepared for us today. Now, before we dive into it, though, I need to share some links so folks can know what exactly is going on. So what I'm going to do, I'm going to bring up my screen really quickly. And I just want to share some of these links so, hopefully you guys will check this stuff out. So first one I want to share, Introduction to Microservices, which I think is very fitting because, like I said, it's Microservices March. And look who it is. It's Nish, right? Nish is here with James Montemagno on the Xamarin Show. And you can find this over in Channel 9. and they're talking about introduction to microservices. So I think that's pretty cool. I'll share these links in the chat too as we go on. But if you want, just head over to channel9.msdn.com and you can see some of these. The next one, cloud native learning resources for .NET developers. And look, it's Nish again. Nish, you all over the place, man. So Nish wrote this really cool blog post on the .NET blog, so the official .NET blog, and he's sharing a lot of cool tips and resources for, if you're just getting into microservices, if you're interested in learning some new things and how to adapt them into your .NET applications, definitely check out this blog post. Again, it's on the .NET blog. So again, I'll share the links in the chat, but again, you can just head over there and check these out as well. Another blog post coming from the .NET blog is from our friend Saurabh. And Saurabh is talking about OpenTelemetry.NET reaches 1.0, which I think is pretty great. I know later in the session, we're going to talk a little bit about OpenTelemetry, what it is, what we could do with it, and how to use it. But again, if you don't know what it is, if you're unfamiliar with OpenTelemetry, one, I hope you stay and watch the show and learn about it. But two, again, definitely check out Saurabh's blog post, also available on the .NET blog. And last but not least, tomorrow. So tomorrow, March 26th, we're going to have another Let's Learn .NET event. And this one I think is going to be our friends Jamie and Shane. Let me make sure. All right, so Jamie and Shane are going to be here. Again, it's going to be completely free. We're going to be on Learn TV and on YouTube, I believe. And they're going to be kind of going through, walking us through some microservice content. And Nish, I believe you worked on some content for this as well, right?
Yeah, that's right. The getting started sample that they would probably use would be the one which is on the .NET website, and also the MS Learn, which is about deploying microservices into the AKS and then just executing it, all the features and other things that you want to roll out. For example, there's a coupon feature that you want to roll out. So that's a really nice MS Learn module that you can try it yourself. But I think there will be a lot more discussed on this one tomorrow. Right. So definitely stay tuned for that one.
Right. So today on the show, we're going to see a lot of demos about microservices, about patterns like health checks and, using OpenTelemetry and feature flags and things of that nature. But tomorrow is going to be a little bit more hands-on. It's going to be more demos. We're going to be going through some Learn modules. And I will also have some folks in the chat helping you along. So if you're finding it a little bit hard to follow or you need some help, definitely make sure that you do that as well. All right. So my time is over. I'm not the star of the show, so my desktop is going to go away. And now we're going to focus on Nish. And learning about microservices. Oh, and look at this really quickly too. So I'm again poking again in the chat. Look, wow, looks like we have some folks from Brazil. We have someone is here from Slovenia. So hey, thank you, Slovenia. Thank you all for joining us. And also Romania too. Wow, we have a lot of folks. Argentina is here. Ukraine is here. Nish, no pressure, man. No pressure at all. I'm just letting you know. The world is watching right now.
That's amazing. That's amazing.
The world is watching. Right? The world is watching.
It's amazing. Amazing. Yeah.
Okay. So I'm going to bring up your screen right now. And
sure.
Why don't we start talking about microservices? Or first, why don't we talk about what is cloud native, and what are some of these cloud native patterns that we're going to talk about today? Let's start there.
Yeah, that's right. I mean, we put the title Cloud Native Patterns, and apparently there are so many patterns out there, and it would be almost impossible to cover everything. I think last time actually last time when I was on your show, Cecil, we covered the resiliency aspect of microservices.
We did, yeah.
We talked about circuit breaker, retry patterns, and other things. It was more into the designing of microservices and other things. And today we are talking about cloud native patterns. It's more to do with, what are the things that is available on the platform to kind of look in, specifically when you're writing applications that are distributed in nature and kind of taking advantage of the cloud, right? And two aspects I want to really focus on today. One is the observability and monitoring, and the second one is centralized configuration and feature flags. Both of it is a very large topic, and by itself, it is a lot of content. So I'll try and go as much as I can. But one thing I try to do on Cecil's show specifically is I try to keep it simple, because he always asks me to keep it simple. So, we will keep it simple. So the demos are going to be very straightforward, simple, point A to point B. How do you do A to get to B kind of things? But we can, concept-wise, we need to kind of put in perspective. So last time we did completely on the demos because that was fine. But this one needs some kind of concepts to be kind of explained to those who are joining fresh and they have no idea about where how this all come up and where all it makes sense and other things. So that's why I have some slides in there. But we will get to demos too.
Sure.
All
And you
right,
know what I
so
also
let's.
believe too is, as much as we love demos, I think it's always great when, we don't focus so much on the logic of the demo, right?
Yeah.
Like we really want to see
Mhm.
the concept. So, I don't care if you're running, you know, a store or a bank or a pet shop or whatever the case is. But I
Yeah.
do, well, at least in the context of this, like I really care about, how can I turn on monitoring and observability in my app? Like how can I do centralized configuration and health checks, feature flags
Mhm.
at my app, right? So keeping the code simple, because I
Yeah.
know a lot of folks ask, oh, well, this is not a real application. We don't really build apps like that. And I'm like, I get it. I get it. But again, we want you to focus on the pieces that are important for the thing that we're going to talk about. And so that's what we're going to do today.
That's right. All right, let's get started. For those who are joining for the first time with the microservices world, so let's put things in perspective. Like, there is this monolithic architecture where you have, I mean, we always had these applications split into multiple layers. Like, you had an app layer, the web layer, there's a services layer, there's a data access layer, then there's a database. But eventually they're all packaged into a single deployable unit, and they are scaled into VMs. So the VMs becomes the, scalable unit, right? Which is fairly simple in terms of deployments and other things. But the challenge with this is when the application is large and you have really large teams, it is really really difficult to kind of ship features into productions very often. So that is why we will look at something like a microservices architecture, which is like you decompose your application into kind of smaller services which focuses on a business functionality. So when you deploy it, they are actually deployed into multiple VMs probably, and they may have multiple replicas as well. Something like a Kubernetes in place can kind of like orchestrate this whole thing together, and services connect to other services. They do not connect to databases of the other services directly. First and foremost, the database itself is split in terms of like each service focuses on its own business functionalities. That means it owns its own data. The database choice is also is defined by that microservice, right? The problem with this is, now the application which was simple, which were in single boxes, which we can actually kind of debug and figure things out, have now this, it has decomposed and it's everywhere, right? It's kind of like a distributed in nature, and that's why we probably need more better tools to kind of like understand and what's happening in the system and go into the details of that. So let's talk about the challenges with this distributed computing in place, right? For example, there's one thing that is very common: system failures are inevitable, right? So you can actually be prepared for a failure, but there's nothing that you can do when it fails. Like you can't avoid failure, sorry. So you can do a lot more things when you fail. So you need to have tool sets to do that. And the failures, you can actually classify them into known failures and unknown failures. And known failures are the ones which you're prepared for. For example, last time when we talked about resiliency, we talked about retrying when things go down, having circuit breaker in place, and kind of those kind of patterns kind of make your system more resilient, and that is where you prepare yourself for a known failure. But in unknown failures happen too. Like there are times when actually when these failures happen, you probably realize that, oh, there was a service like that in this place, first of all, which was failing. Those kind of situations happen, and you may even discover a code that you probably thought it never existed in the first place. So there are unknown failures there, right? And the other challenge, as I mentioned earlier, the failures are now distributed. So gone are those days when something goes wrong in a particular box, you could just log into that box and try to figure out from the logs and what exactly happened and kind of like get to the bottom of the issue. But now we're talking about multiple systems coming together, multiple services. It becomes a challenge because you have to now probe failures in multiple places.
Right. And
The
you know
other.
what? That
Mhm.
reminds me of just, not too long ago, like before I even started working at the company. And, we had this architecture where, like you said, it's a lot of machines. We weren't in the cloud,
Mhm.
but we were on premise. But even though we had a lot of machines, it was really annoying to have to go into log into one machine. Oh, was a
Yeah,
problem here? Was a problem here? And then logs were in so many different places, right? There was the
exactly.
Windows events thing that we had to search
Mhm.
for. Some
Mhm.
applications logged to disk.
Yep.
Some of them were sending it in. Some people were logging into databases, and so
Yep.
now it became very challenging because now we had to aggregate all that information and to get a holistic view of what
That's right.
exactly the problem was.
That's right. That's right. So many issues, right? I mean, just to get to that bottom of the problem, you
Yeah,
had all these hassles in place, and so is the legacy systems, the APMs that we used in the past will not work in this case because you need that distributed nature in place. So
right.
these are currently the kind of identified challenges. Now let's look at how we can solve these things, right? So we'll go into monitoring and observability, and though they sound very similar, but they are two different things. Somewhat like. So monitoring is it tells you where the problem is. So it tells you, okay, this system can fail, or it can give you those information. But observability is all about going deeper in understanding why, and it can give you more probing informations like what VM, what node. You can go into all those kind of details, and you can get to the point where you can kind of start fixing those issues, right? So the three key pillars of an observability, that, as they say, is the logging, the metrics, and tracing. Logging, we have been always been logging ever since we started writing the hello world applications. We always wrote console.write or printf or anything that's just a fair simple log that goes into the console, right? And logging gives a lot more information, and metrics is basically the numerical value, and it also is based on the time series database. That means you can actually relate your application's performance based over a period of time, and things like that. And tracing is an important aspect, which is, as the name says, you trace the entire request. So when you look at distributed computing in place, you do not know which VM, which node, which container, which service is actually connecting and taking the request. So you want to get that entire holistic view of it, and that's where distributed tracing comes into picture, right? And then we also, one more thing I wanted to add here is the health check, and which is the key thing in terms of understanding if the system is up or not, right? So you will probably implement a health systems to query your services if they are up or not, right? Um, so this is what we want to cover today, and we'll also look at centralized logging, which we probably will be left out with a little bit of time, but I'll try and show you places where you can actually grab more information about that, right?
Cool.
So cool. So let's get started with the health check. Now, talking about health check, as I mentioned earlier, it is technically two things. One, it needs to tell, the services need to tell, is the system running, and the other is, can it perform tasks? And they're two different things, because it's like the heartbeats, right? Or it's like the more like a binary thing, which says, okay, if you say the system is up, that means you're good. But there is also the other side of thing, is, can it perform tasks? And that is an important aspect, and that comes into picture when, for example, your service is up, but then there are hundreds of dependencies that you probably are relying on. There, not all of them are up, so you can't perform tasks to complete it. And that is something which the health monitoring system should be aware of. And depending on what health monitoring system you use, you probably will be using, you will be answering similar things, and letting those systems know. And for example, in a Kubernetes world of things, they are represented in two things. Like, one is the liveness probe, and the other is the readiness probe. So liveness probe is all about, hey, is the system alive? That means your application have to bake in some sort of code to say, yes, I am alive. And the second thing is, are you ready for performing tasks? And the system has to say, yes, I'm ready, when you will perform certain tasks to figure out, is the service ready, right? So there's just two different things, and this is very key if you're working with Kubernetes, because in liveness you want to be really quick and say you're up or not, and that could be bare minimum just a ping, and you respond back with 200 status code, and that should be good enough. And you should not put any
Yeah.
other code, because if you go wrong there, the Kubernetes, if you don't respond to and read immediately, it'll restart your application. So that's the key thing there. But in the
I think
readiness
this is a
probe,
good distinction. I'm sorry to cut you off. I was just saying, I think
sure.
this is a good distinction for us to have,
Mhm.
because kind of like what you said, it's like, what does it mean for something to be ready to go? Like
Mhm.
what does this mean to be, hey, my service is up? And like, what does up mean? Right? It could
Yep.
be, yes, the machine is up. It could be, yes, it's not throwing errors or exceptions or anything like that. But can it reach the database? Can it
Yep.
reach to Redis? Can it, connect to like some external service that it needs to do its job? You know what I mean?
Correct.
And so then now we think about health as like the health of the application, like the individual
Mhm.
instance of that service, or the health of the
Mhm.
machine, or the health of like the architecture, right? Like all of the different pieces that kind of plug together to make that thing do, the job it's supposed to do.
That's correct. So, and that's where the readiness thing comes into picture. And the important thing to know is in terms of Kubernetes, if the readiness probe does not respond, if it says not ready, that means the traffic itself will not be diverted there. So there's no sort of cascading failure that will happen if your service is not able to handle that particular task, right? So it's an important thing. So that's why you need to and the whole aspect is like in terms of Kubernetes in the YAML file, you basically provide these two paths, which is like it has to be part of your service, and the service has to say, what is the path which will tell Kubernetes what does liveness mean or what does the readiness mean. In this case, there's liveness and HC. So we need to write this thing within our microservice. So that's what we will try and look at it today as part of the demo. We're going to implement a health check in ASP.NET Core. We'll look at a nice little NuGet package, ASP.NET Core Diagnostics Health Checks, which kind of like helps in adding dependency checks and other things. And also we'll look at Health Check UI, which is a dashboard that you can build in .NET itself for creating that health monitoring system, right? All right, let's look at that one. So I'm going to open my terminal. Okay, this is my microservices project. And you can see that like I have more than one service. So there's a front end, there is a back end. So backend services, I mean, if you have seen our previous talk, it's just a weather service, which basically gives you some weather data. Right, let's run this for the matter. Let's say I'll do a Thai run. Cecil, are you using Thai nowadays? It's become so easy for me in terms of.
Yeah, I'm a big fan of Thai for sure. Particularly now, since I don't have to write any Docker files, I could just Thai run and it just does it for me. I love that.
Exactly. So it gives you this nice dashboard as well. So it kind of tells you like, okay, what are the services that's running? You can go into the logs of it, and it also gives you this port, like automatic ports in your code. So you don't have to like really hard code these things. So let's go to the weather. So it's a static weather data. You can see that, and if you refresh it, it just refreshes some random data in there, right? So it's very simple. So let's we are technically not writing a microservice. We're just writing simple web APIs to show multiple services there, and how do you go and implement health check. One other thing I want to show you is this web status app, and this is an app that is written in ASP.NET with just 5 or 6 lines of code, and that's all. It's just you create an ASP.NET web API or even an empty app project, and then just write 5 lines of code, and you get this entire dashboard. And if you look at this dashboard, it actually tells you what does health mean, right? So there is a self. The front end has a self health check, which itself is saying whether it's healthy or not. But it also is depending on a backend service, because if it has to complete a task, it has to connect with a backend. It is also doing it's another check, right? In terms of backend, if you look at, there's a self, but then backend does not depend on anything, so it is healthy. But this is where we are going to implement something new here, which is like we will go and implement a code, which is we'll implement caching, like bringing in a Redis cache into the backend, and kind of like instead of every time you send a random value, you probably want to wait for 5 seconds and send them a new value. That is, you implement a cache, right? So for that, I'm here at Weather Forecast Controller. What I'm going to do is the demo tricks is just uncommenting codes that it's going to work, and commenting codes that you don't need now. Right? So that's a simple thing. So that's all I did. Now what it does is actually it's actually injecting an iDistributed cache, for which I have configured Redis connection string already in the program.cs, and then we look at this activity. This is part of the distributed tracing. We'll look at that later. I'm using some loggings and things like that, which is fine. I'm also using some sort of a feature manager, which basically is like if I'm running in production, I want to see if I want to connect to an external weather API. That means I'm not sending the user with any kind of random dummy data. Instead, I'm actually connecting to a real weather API that is using the Azure side of things, right? So so this is where the feature manager that I want to get to at some point. And then I have the static data. Basically, static data is the one which is getting some random data. It should be here. Yeah, so that's just a random data out there, right? And then we have this cache. Cache works for 5 seconds, and then it just refreshes, right? Now that I have done this, now this has a dependency, right? I need a Redis cache. So first thing I need to do is I need to make sure the Thai knows that I need to run a Redis image or create a container for it. So I'm going to uncomment this code. So that means when I run the Thai run, it will also bring in the Redis, and I also have the connection string configured. So I'm all good to go. Like if I just run it, it should just send in values from the cache, which is fine. But the next thing that I need to do is, because this is there's a dependency on my health of my system right now, I need to go and configure the health check there, right? Let's go do that. Excuse me. So here are the two endpoints that I talked about. So this is we're using the ASP.NET Health Check implementation. There's endpoint that you can create called with using map health checks. So I'm using a HC endpoint. So this is basically the readiness probe, which means like, at what point do I tell that I'm ready to accept traffic, right? And then there's the liveness probe, and the liveness probe is basically telling, I'm a live signal. So each of it has its own representation of it. For let's get into this. There's an important thing that I need to show you. This is the one, add health check. So you basically add health check first. So basically you implement I health check. So I health check in the I health check will have a method where you will kind of define what does healthy mean, right? In this case, for it to be healthy, until now we were just using self, which is basically if you're just hitting the endpoint liveness, it is just going to respond with the healthy endpoint, which is actually configured. In this predicate, we just say, okay, pull out all the health check that are configured with the name self, and if that is there, then we are healthy, right? So that will respond back with healthy. But now we're going to add Redis. So you can see that I'm just going to use .add Redis, and you'll be wondering, what does that even mean? Like, how does the system know what add Redis means, right? So what I'm doing is instead of me implementing the I health check to define what connecting to Redis is healthy, like to define what that means. Instead of that, I'm using an external library called the ASP.NET Core Diagnostic Health Checks. This is from Zebril, and it's really nice library. So it has all the health checks implemented for each of the things that you probably will be working with, like Cosmos DB, Document DB, MySQL, SQL Server, right? So like, for example, in this case, we are talking about Redis, but we can quickly go into this SQL Server one. You have the SQL Server health check. You can see that there's an iHealth check implementation. It has this method called check health async given by .NET, but then you define what healthy status means. Basically, if you're able to make a connection to it, that means you're healthy, right? So when you're creating this connection, you probably want to have a really, really simple SQL statement, like something like select one, right? That should be good enough because you want to be quick in responding. So similarly, this one has, let's go back and see what does the Redis health check look like. So this one, Redis health check. So you can see that there's a check health async method, and it basically makes a connection ping, and then as long as it's working and there are no exceptions, it seems to be healthy, right? So, but in case of my .NET code, I just had to add Redis and just configure a tag name to it, and then say, if I'm able to make the connection, that means I'm good to go, right? So let's go.
Nice. So then that means that in your backend code, right? So in your CS project for your backend project, I know ASP.NET Core, like what we ship as Microsoft, we have a health checks package. But then what you just showed was like a community run collection of additional packages with product specific health checks. So there's, like you said, there's a specific check for Redis, and there's a specific check for SQL Server and Cosmos and et cetera, et cetera, et cetera. So to get that, I could either go on NuGet, or I could, in Visual Studio, I could install that. But that's not like something that's in the box by default. I have to like go and get it.
Correct.
And bring it in, right?
Correct. And that also, like, when you're building systems and you probably have a legacy system which you depend on, in that case, you can actually go and implement iHealth check and write your own, right? For all the popular ones, for the cloud native ones and other things, there is libraries to help you with that, right?
Cool. That's awesome.
All right, let's go and get to the dashboard. So multiple monitors, this is an issue.
When you get too many things to look at.
Yeah, too many browsers, and I kind of get lost in this. All right, so now we're going to the web status, and if you look at the web status, and you can see this backend, and quite easily now it has this Redis check, and it tells you that it's healthy, right? I can probably delete the thing, and it'll show you that it's not healthy, but then it'll be cascading off the failures. Like for example, because front end is depending on backend is depending on this one, and you'll see this thing, right? Now, what you see here, this is the health check UI thing. This is a web status project. I'll just quickly show you that one too. It is basically, it's again from Zabril itself. So if you go to the web status project, if you go to the CS project, all that I'm doing is ASP.NET Core Health Checks UI. I'm just adding it, and because I'm just using it local, so I'm using an in-memory storage for storing all those health check informations and things like that. Okay, and then if I go into the startup.cs, it says add health checks UI, and basically now looking at the endpoints, right? In this case, I'm looking at the HC endpoint, which basically is the readiness probe that we will configure in Kubernetes later on. But for this web status, I need to know, because this is a dashboard that I'm building, I need to know all the dependencies too. So, and that's why it makes it easier for me to just kind of like have a endpoint that will tell all the dependencies as well. So that's about it. That's all you need to write in there, and just map the health checks UI path where you want to show that, and the whole dashboard that you saw, it just magically comes up, and you can actually go and customize the styling and make it look like your own health check and that kind of thing. So this is a pretty neat trick.
Nice.
So that was easy, right?
Yeah, that was pretty good. And I love the fact that in this particular app that you're showing right now, that it makes me feel like I can aggregate health checks from across services. So I don't have to have the UI in every single microservice. I can have a monitoring app of some sort, right? And I can have the UI in there, but then I can point it to like these different endpoints, and then now it'll just aggregate that information, right? You can go to those different services, pull in those health checks, and I can see it in one consolidated view about, let me know, like, what's going on and how things are going.
That's correct. And the important thing to remember is these endpoints have to be reachable by these implementations. For example, if you're deploying this to Kubernetes, the service discovery within Kubernetes have to kind of like be able to reach there, right? So that is something which you need to be aware of.
Nice. Okay.
Okay, so that was about health checks, and let's move on because we have a lot more to be talking about. Let's talk about logging, right? So talking about logging, I mean, believe it or not, the truth lies in the logs. Okay, so no matter what tooling you use, if you want to get to the problem, it's always in the logging, and that's why you need some tool sets to kind of like build some better logging. For example, like look at this one. It has there's an exception called system.net.sockets.socket exception, which is great. But you may as a developer, you may be looking at, okay, I can look at the call stack and probably figure out where exactly the exception is. That's correct. But think of it in hundreds of different services and hundreds of different applications that it'll work with, right? So wouldn't it be nice if the logs had some more information? For example, in this case, I'm actually showing you some things like, what environment it is running on. It's a dev environment. Okay, what request path and things. But this is fine. I mean, this is something which you're getting it by default with some sort of tooling with distributed tracing and things. But logs can have more information. I did not add those information here because I obviously didn't want to complicate these things. But it could have information like, for example, what runtime am I running in, or what Git commit was used to deploy this to production, or for example, what team is working on this, right? So you have hundreds of services and you have a socket exception happening on one of the services, or let's forget the socket exception. So your socket exception is something straightforward to probably figure out from the thing, but it could be some kind of business exception where you will probably have certain coupon code that when you're using an e-commerce application for a certain region, it is throwing an exception. And how do you kind of trace it back, right? So then you want to log some more information into the logs so that you get to the bottom of this information. And that capability needs to be there in the logging tools that you're going to build.
Yeah. And I always, when I would talk to younger developers, like people just getting started in career, I always tell them logging and exception handling are two of the most underrated skills as a developer. Very, very underrated. And I say that because, it's all good and dandy when things are working well. But when they're not working so well, how do you figure it out? Where do you look? How do you solve the problem? How do you deal with, issues that you weren't expecting? And that's why I always think logging is it's almost like an art too, to a sense, because At the same time, you don't want to have logs littered across every other method of your code, right? Because then you'll be writing a logging application. You'll be doing more logging than business logic. But at
Right.
the same time, too, you want to have enough that'll give you context, right? So
That is
it's like, as logs come in, I want to know I want to know what happened, but I also might want to
Mhm.
know what happened just before, or if possible, what happened just after, so that now I could
Right.
kind of get an understanding about like the path that my code took to see these
Mhm.
types of things, right? And that's and
Mhm.
then that's one of the things for me why I think logging is important.
Absolutely, and you rightly said you need to log enough to get to the bottom, but you shouldn't log something like PII or sensitive information. You need to be very, very careful in what you log,
Yeah,
and how if you're logging something like that, you need to be aware of how many days you can retain it, and kind of like work with the tools to make sure that you don't retain things that you shouldn't be retaining for a longer
for
time,
sure,
right?
for sure.
So yeah, as you rightly said, I mean, as I mentioned earlier as well, the truth lies in the log. So you need to know how to go to the bottom of it. So you need to have those skills, and I love those skills. I mean, and that's a good way to learn, as you rightly said. For the new developers, the right place to start is actually start exploring logs and start debugging things, and that's when you learn a lot more about the application than you will learn from just reading the code, right? So when you talk about logging, and now let's talk in terms of distributed applications, and there are three things that is very important. One is you need to have a structured logging. I mean, text-based logging kind of doesn't work really because the text is lost in the noise, right? But when you write structured logging, it's easier to kind of systems to probe, and you can kind of like make meaningful decisions about it. And I'll show you. And this is something which you might have to write in the code. It doesn't have to be .NET. It could be any code. You need to write structure logging so that you can retrieve it later. And similarly, now that the VMs are many, the nodes are many, the controllers are many, the pods are many, the services are many. When it happens that way, you literally can't go to a physical box to check on the logs. They're gone of those days, the rolling file systems and other kind of things. Now it's all about having a centralized database, or having some sort of collector, and then you actually ingest all the logs in there. And that also means you have to go and you should be able to search and correlate them, and that's a key important aspect, right? How do you correlate between one thing to another thing so that you can make sense of those logs that were put in? Like, if you really just generally go to the centralized database and try to search for information, you find so much of noise. So
Yeah,
again, it's another skill to kind of relate and kind of make sense of the situation there. All
yeah,
right, so let's look at these things in demo. One is structured logging in .NET using Serilog. And for the sake of time, I will be avoiding writing any sort of code from now on. And I'll show you the implementation part where what has been done. And we'll share the demo with you later on so that you yourself can go and check it out. And also we look at centralized log with two collectors or two aggregators, Sec and Azure Monitor as well, right? So let's go look at the code for where the implementation of structured logging happens, right? So if we go to the program.cs, okay, I'm in the wrong one. Let's go to the backend.
and then while you're looking around, we did have a question come in from YouTube that I think is related, and we could talk to really quickly. And Carol from YouTube is asking, isn't centralized DB breaking the microservice pattern?
Okay.
So what are your thoughts about that one?
Yeah, that's a great question. And centralized database with respect to business will actually break that pattern. But this is more from the infrastructural angle. You're actually looking at the distributed trace. Even for some reason, the trace is not up, the database is down. You will not be able to reach the system. That's about it. But your businesses will not fail, right? So think of it in that way. You when you use some kind of systems behind the scenes, like a central log collector, that would be easier for you to kind of phrase the information, because you have to look at it from a holistic angle, and not from a single particular information. Otherwise, if it's not in one place, it will be difficult to correlate and figure these things out, right? So
Yeah, for sure.
and mhm.
Yeah, like the
And that-
business logic can definitely be siloed as necessary, but again, when you look at trying to solve problems, I need to know what happened across the board versus
mhm.
just in one place. And again, that's At sometimes centralization of things is a good thing.
Yeah. Yeah, I mean, there are also debates happening about monolithic is the still right way to do it and other kind of things for the simplicity and things like that.
Yeah.
All right, let's go into the logging thing, right? Right. So let's talk about logging. Cecil, do you want to a little bit explain about the .NET logging system so that I can take it from there?
Sure. So I believe it was whenever .NET Core first started. So this was a
Mhm.
couple years ago. Um,
Yep.
they introduced a lot of interesting abstractions to the framework. So DI being one, configuration being one, but then logging being another one of those things. And I always thought that was great, right? Because if you look at the ecosystem, there was always so many different things to log, right? Like there was,
Yep.
Serolog was always there. There was Log4net that was there. Um, there was a S there's a whole bunch of them, right? There's tons of different
Yep.
things that do logging. But that means that every time you wrote your application, you had to like rethink, and I had to reinstall a NuGet package, and I had to configure this thing, and so on and so forth. And you didn't really get maximum reusability sometimes. And then it
Hmm.
would also mean too that like the framework code and then your code might be using completely different loggers, right?
Right.
So in the effort to one with ASP.NET being cross-platform now, because
Mhm.
a lot of people still don't know that it runs on Windows, Linux, and Mac, and with it also being cross-platform and open source and needing to be able to capture information across these systems, we
Mhm.
can't just log to the Windows Event Store like we were doing before, right? We have to,
Right.
consider a wide range of options. So now we have like the built-in logging abstractions, which give us tons of great options for doing structured logging, like like you were speaking to not too long ago, but then also to being able to plug in different logging targets. So targets being, I want to log to the console, I want to log to
Right.
an in-memory thing, I want to log to the database or file or whatever the case is. But now the abstraction is consistent, right? Like meaning
Right.
like I don't have to, you know, the way that I log an info message or fatal or error or a trace message is still the same.
Mhm.
It's consistent from an API perspective. And then now as I create my logger, I just need to, figure out like
Yep.
what are the actual targets that I need to send them to.
Right, right, right. And what we are doing with the Serilog in this case, actually, we are actually plugging it into the existing system. So there's nothing additional that you need to do. And what to explain structured logging better? Again, lost in the browser. I want to show you the Serilog website itself, which kind of explains it in a much nicer way. For example, if you have the position with some sort of object which has more information like latitude, longitude, and then when you do the logging information, you can actually put that entire object into the log in this format, and it will completely serialize them and give you this more key value pairs when you log. So which means that now I can actually go and query, okay, what were the responses that were given when we queried a particular endpoint with latitude 25, right? So you can kind of like come up with these kind of questions, and then the logs can give you more information about those things, right? So that's the very starting point of understanding structured logging. So we're just going to use Serilog again. It's a NuGet package. You add it to your project, and then you configure them. And here in this case, I'm actually configure. One is about structured logging, and the other is about where do you want to see it. Like, you need some sort of aggregator to see the entire logs in one place. And I'm using two of them. One is the application insights, which is Azure based, and you can actually monitor those things there using Azure Monitor. The other is an open source. I'm not sure if it's open source, but it's free for personal use, and they also have a commercial offering called Sec as well, or Seek, and basically I'm configuring these two of this, and I'm also writing it to the console as well, right? So in the weather controller, if you look at when I was retrieving the weather, I did one more thing is I'm logging the entire weather information here, right? Just to show you that, hey, here's the object that came in. Sorry, here's the data that came into this object from whatever query that I made, but I'm actually logging that entirely into the log because I'm using structured logging. Right now that that is done, I can go and search probe this information. For example, I can let's go to the um, um, where are my dashboard? Let's see. So refresh this. So this is my dashboard. So you can see that I'm also using sec here. So I can go into the sec. So before going there, we can do, because now that we have actually made one, okay, we don't have it here. So let's go back and go to the front end and refresh this page. Let's go back to the dashboard, um, and go to the backend code view, and you can see that we also said write to console. You can see that the entire data is also written to console. Now in console, it may not make sense to kind of like query this data, but I can actually query this data based on, okay, I want to know how many times maybe a mile temperature was sent, right? So I can just copy that mile thing and go to some query like the sec, which I need to go back here and go to the sec. And here you can see this whole bunch of information that's getting logged. I can see this mile. So now you can see that I'm able to get into the more details of this information, right? So it just goes into, and you can see that, it's not only logging just the data, it's also logging with some kind of action ID. There's a trace ID, there's a request ID. um, you know uh, because this is a demo data, you probably may not make sense, but in a business transaction you probably will have some more information to kind of like make more sense of it. Like, for example, okay, I want to know what is this count by value, how many applications have worked on it, right? So we can see that, charts and other things, which gives you this nice dashboard of configuring and things like that.
So that's pretty cool. So from
Yep.
my understanding, structured logging is almost like logging a dictionary, right? Like there's key value pairs. So I don't just get a string of text, but I get, again, that contextual information. Because that contextual information, that dictionary is made it structured, I can now issue queries against it. So kind of like you're saying, hey, if I logs the correlation ID, right? I could say, hey, give me all of the requests that match, or give me all of the events that match this correlation ID. And now I could, based on the correlation ID and maybe the timestamp, I could watch the flow of information from top to bottom, and I could see exactly what happened.
Yeah, so that you also actually touched upon a brief aspect of distributed tracing to understand the trace of the entire information as well, right? You get those kind of information as well. So let's look at one more thing over here in terms of logging. You saw that I was actually logging into the the log application insights as well, so where I can query here. So for just get to this one, what I did is I used Thai deploy, and actually I have deploy this to my Kubernetes.
So you're running like a local Kubernetes cluster?
No, this is running in AKS right now.
AKS,
so this is
got it.
configured to my AKS. So let's port forward this so that we can get to this using front end 9001, which is fine. And I'm port forwarding to 80. And you can see that all of these web status, SEC, Redis, and all those things is all there. But let's go into localhost 9001. And now it's actually, you can see that, this one is actually working with Azure weather data, which has these information like Seattle, London weather. So these are real information. These are not dummy data, right? Because as I deployed to production, I enabled the feature to work with this one, right? So now I can just go copy this one, let's say all the summary that were cloudy, and go into my log insights and search for that one, right? So, and take a bit of time probably. Yeah, there you go. So now when you go into this, you can see that, it gives me this whole trace of information. But the interesting thing is, if you hit on this view in logs, it'll also give you this nice custom query for you to kind of like execute this, right?
Oh,
And
nice.
yeah, so you will get more information. You can actually configure some more things. For example, in real data, when you're working with multiple services, probably you had a production, you wanted to ship a beta feature, and you really want to understand how many people are using those features and how many are using certain things, or how many exceptions are happening and things like that. You can kind of like trace back in those instances. So for example, you can see that this one also gives you those information, which cloud role instance was running it, what other levels, like the client type, how it reached, and also there's custom dimensions, which is nothing but the data that gets logged here, right? Also all the trace IDs and other things which we actually captured, we saw it in the sec. It has the similar things that is also being logged in. So just by writing that, from the seri log, we just adding a sync saying, okay, go and log this to application insight, we get a ton of information already on this Azure Monitor side. And those, you were asking about why would we want a centralized DB. yeah, it is going to be difficult to maintain if you were doing it yourself. But then if you look for some cloud managed services, that's when things get better, and it'll give you, you have this whole range of tools that you can use it to kind of make your applications better.
Right. And then, so we're looking at this right now. It's
Hmm.
inside of Azure Monitor, right? So
Right.
not I keep wanting to call it Application Insights. It's inside of Azure Monitor, and
Yeah.
the language you're using, right?
Hmm.
The query
Hmm.
language you're using is actually called Custo. So that's
Right.
Kusto, right? And so using
Right.
Custo, and I think you could use Custo in some other parts of Azure as well outside of Azure Monitor. But again, you could use that to query events and inspect logs and really dig into that structured data. So again, you showed an example of showing charts and graphs and things of that nature.
Oh
So
yeah,
it kind of
there's
sounds for
so
me,
much. Hmm.
yeah, it kind of sounds for me like I could use Seek or I
Hmm.
don't know, your log aggregation tool of choice locally, if
Yeah.
I wanted to. And if I'm running on premises, like those are great options. But now when I move to the cloud and using Azure, I should be able to point to that as well. But hopefully I could do that without a lot of interruption to my code, which kind of goes and plays into the point of, hey, we have a very structured, consistent API model for doing logging. Now we just
Yep.
have to change the target, right? And once the target's changed, the rest of our
Yep.
application code doesn't need to change. It's already instrumented for that.
Correct. Correct. And I feel like explaining a lot more in this dashboard because there's too many things there, but we'll just get back to the
Yeah, sure.
presentation and connect some more stuffs, which are really cool. You probably would have seen something called as tracing that I was denying to touch there at that point of time, and that's because I wanted to get to explain this
Sure.
before we go into that. And that is about distributed trace. And it is also called as distributed request tracing, which is me from the point of initiation of a request to the entire life cycle of that particular trace. You need to get the whole information, and that information probably need to know for you need to know probably how many seconds is this taking. Some of the services may take longer than that, and then a few other things like you have a new method that is introduced, and then you want to understand how is that method performing. So you need to get those information, right? So this is technically understanding from a holistic view. You have the entire cloud, a lot of services, a lot of things that is coming together to work together, but you want to get to the entire information and you want to get deeper into these things, right?
Yeah.
So that's where distributed tracing comes into picture. And with Azure Monitor, that's baked in, so you will get those information there. If you're specifically if you're using application insights, it has those built-in mechanisms to instrument your code, so it gives you those information right there. But you can also use things like Zipkin and other things as well, which is what we will look at in a bit. To just understand this better, I want to touch upon two important things. I mean, there are a couple of more things about tracing. One is what trace really mean. It's just basically the end-to-end request tracing, and every trace is unique because it has a trace ID, and that ID is technically added to the header and it just flows through. It doesn't matter what you call under the hood; those entire trace ID have to flow through it, right? And similarly, there's something called a span, and span is basically a unit. It's the smallest unit of one of your tasks. Like it may be a method call, it may be something you're calling to a messaging queue, or any other external dependencies, right? So that will have a unique span ID. And the span will have parents as well. Like you'll have children, so you can connect back using parent ID. You will have multiple, maybe one at one point you are connecting two different services. That means they go parallel. That means they'll have different span IDs, but they'll have a single parent ID, which is the span ID that initiated it, right? So it's something like that. So when I talk about all these things, one thing you probably will be realizing, there are a number of cloud tools out there, right? So how do we standardize there? And that's where specifications like open telemetry comes into picture. And as Cecil showed you in the start of the you know and for this show, we talked about the open telemetry. Saurav actually wrote about the open telemetry being version 1.0. And I think, Cecil, you should actually get him on to explain more about open telemetry, because I got into this when he pinged me and told me about
Mhm.
how we can bring the eShop on contains one of the popular reference samples and enable open telemetry to it. And that's when I looked at it and I thought, like, okay, this is a good time to actually bring in that into
Yeah.
our demo. So I wrote that completely newly on this one. And technically, open telemetry is two things coming together. There were open formats like open tracing and open census. Open tracing is more like an API and open, which is all the people who are consuming code as well as writing libraries. They write it by defining well-defined, based on specific specs. And OpenSense has been used by Google for a very long time, and it actually has more implementation side of things, like the libraries and other SDKs and other things, right? So technically, they're all specs. So when you follow this open telemetry, when this logging and tracing happens, they are followed by a certain standard. So that means it is vendor neutral. You can have a .NET application and Node.js application connecting with each other, but this entire trace can flow through without an issue because both of them will implement this open telemetry, right? And similarly, if you want to go from one vendor to another vendor for collecting the trace, or you kind of like seeing the dashboards and other things, it can work with anything, right? So you basically define that very clearly in the approach. So let's look at OpenTelemetry API in .NET, and we'll look at Zipkin and Azure Monitor as well, right?
Sure,
Okay,
let's do it.
All right, so OpenTelemetry, now that we are in the trace, I just want to quickly show you this trace thing. So you can see this is the end-to-end transaction details. And right now, I did not log anything meaningful here. So that's why you're seeing all these things here. But when you log something meaningful, you can actually do a lot more things, right? For example, let's go to this one. So this is the HTTP. So this is the outside code that is actually going out. Now I can click on this, show what happened before and after this dependency and user flows. And it kind of like gives you that graph of those information, how they came in the index page and the weather forecast, get method. And now think of it in hundreds of different flows out there. So you kind of understand how the user is like navigating through your application and what services were being called and that kind of things, right? So and a lot more information that you can actually add it to these trays, right? So okay, so this is distributed tracing. I'm pretty sure I'm forgetting a few things that were pretty cool, which were part of the Azure Monitor, which I forgot to show you. Okay, let's
Does
go
it
back
have
to.
an app map? Can you do like the app map thing?
Oh yeah, yeah. That's pretty much it. Application map. So there you go. So now we have this application map. It tells you about like what are the things that we are connecting with. So there's a backend. There is also, this is the API that we were calling. That we were making the external calls to it, and it's pretty unique. Actually, you know what? Let's try something new. So don't blame me if this fails, but
No worries. We won't hold you responsible for any code that gets harmed in this demo.
yeah, so this is pretty much the last part of it. So I think we can just try around something. So what I'm trying to do is I'm actually trying to delete delete pod, and I'll delete this backend for just for the sake of seeing how the failures happen and how this is being traced back. So you know that Kubernetes, when you delete a pod, because it has to stay true to the configuration that you set with it, so it'll bring back the pod alive back in no time. But there will be a fraction of seconds where the pod will go down, and I need to make a request there at that time.
Nice.
Refresh this. Let's see. I think it would have. Let's do that again, which would be a new pod number. Let's see. Okay, let's do this. Okay, refresh. Exception. Yes, that's what I wanted. And let's go back to the application map, refresh probably, and see if that record. Oh, there you go. So it basically had an exception at the Zipkin level, I think. But the backend seems to be fine. And that's because it probably. Oh, yeah, there you go. It takes a bit of time, but it actually comes into the picture. So you can see that, there was faulted, there were cancellations, and you can actually now go and investigate failures, like what exactly happened. And this should give you more information as well when it comes up.
Nice.
So, yeah. So, now put this in perspective, like with hundreds of services coming together to make your application run, right? All right. So, and you got to believe me that will come up and you'll have more details there. Oh, there you go.
Exactly.
All right. So now let me show you one more thing. Let's go back to the
I also love how much detail Application Insights gives us. Like you
Right.
could really drill into, all the way down to, the log and the exception and all of that. And then it goes all the way back the other way and gives me that high level view of, well, what are the different applications that are making up this thing? Um,
Yep.
so regardless of whatever type of information you need, you can start up high and then you can drill down lower and really understand it.
Correct. Right. So now, if you look at this one, now I'm using Zipkin. It's another open source nice dashboard. Um, so if you run this query, basically go back to front end. Let me just refresh it so that I get the right data. Refresh this. Zipkin, run this query, and so you can see that, right now, if you look at this thing, so it gives you this trace of each of it. And now you see this interesting aspect. There's a weather forecast that was called, and then there was this 307 redirect. And the very next request was the weather forecast itself. And that's something strange, right? If you go inside it was a HTTP colon call. But if you go to this one, it's a HTTPS thing. So it basically traced that redirection that we actually had put in .NET. And now you can actually, you can get more meaningful information in real time. But this is a good point to understand, okay, now I can fix that. I can further optimize to go and fix this to have direct HTTPS calls and not do the HTTP colon calls, right?
Yeah.
So and similarly, just like how you saw it in the other one, it also you get this kind of dashboard for understanding
Nice.
dependencies and other things, right?
Yeah.
And what does it take to have these things in place, right? Then that's what we need to look at next, which is basically if you go into the startup.cs, I'm actually adding this application insights telemetry.
Okay.
And also the open telemetry configuration. You can see there's add open telemetry tracing. So this
Okay.
is what configures the open telemetry. And in this case, I'm actually using a Zipkin exporter. You can use any exporter, Jaeger or anything that is Azure. I think that one is in preview right now, but you can use any of those exporters as well, right? So, and adding all the instrumentation also kind of like automatic, whatever you saw related to .NET and that kind of things, it is all the application insights and other things which is doing the magic inside it. And if you want to write something more custom, then you can actually write this one. This is what I was talking about earlier, using activity source.start activity. And
Yeah, I was
here,
wondering about that. Like, what is, because that doesn't, I don't see a log statement. I see an activity. And so that
right.
sounds a little different to me. So I was kind of curious, what role does the activity play in my distributed tracing?
Right. So by default, if you just go to the startup.cs, I think, where's the main method is in the program.cs, right? If you just define activity default ID format .w3c, all those .NET code that is under the hood will actually participate in the tracing. So all those, tracing related information that is getting generated based on the Open Tracing API, it'll all be done there. Now, remember I talked about that everything has a trace ID, and then you can actually have your own span IDs. So
Yeah.
this in .NET world, activity can be related to a span.
Okay. Got it.
So when you do a start ID, it basically creates that span ID for you, and then that becomes the context of information for what you're going to do. So in this case, we are actually making an external weather call, which is an external weather API. So I want to have that in a span, right? So that's why we're doing that.
Okay. So now when we make these external calls, so I'm guessing I'm using stuff like a gRPC thing, or I'm using HTTP client. Once I set that activity, and I'm guessing once I configure some things in startup.cs, do my external HTTP client calls just automatically get captured and become a part of the trace, or do I have to do something else with HTTP client to get that to work?
Like for example, like if it's totally external, even though these trace IDs and all gets cascaded into it, but you won't be able to get it because you can't collect what happened the other side of things.
Sure.
But within your internal systems, you can. And
Okay.
the way it
That
works
makes
is,
sense.
yeah, it works on the HTTP headers, right? You add all this information in the header.
And that makes sense. And then another question really quick from some folks. So in your startup.cs, again, you did show the application insights telemetry configuration. Do you still have to add that, or do you? So I guess the question is, so we have open telemetry and we have application insights. Can I just use open telemetry to point to application insights, or do I still need both of those?
You need both of those. So one is doing distributed tracing, the other is logging information, right? You probably will
Got
have
it.
those log related ones, but tracing related ones are like it has more information related to the code that you're using, the other SDKs that you probably are using. Even library manufacturers who can actually instrument their code to implement open tracing. So you
Hmm.
get all those kind of information added in when you use that one.
Got it. Okay. And then one more question, really quick. And I know
Mhm.
this guy's been trying to get this question in for a while. The person's asking, if we choose to log into App Insights, how can we
Mhm.
mask sensitive data from the logs, like remove customer information?
I don't know the answer to that. Probably we need to check the app insights and see if there is any kind of like logging some sort of sensitive data and that kind of things. But I'm not
Yeah,
sure.
I know by default, Application Insights would not capture certain things.
Mhm.
So, like IP addresses, for instance, like that's considered PII,
Yep.
and those types of things. If you do it yourself, you know what I mean? Like if you intentionally add it to your logs, um, that's kind of up to your discretion, right? Like I don't think there's any intelligent filter or machine learning thing at this point that could look and say, oh, hey, Nish is logging an IP address or Nish is logging a password or whatever. Like all it's a dictionary, right? It's key value
Mhm.
pairs. And so if you don't want it logged, you shouldn't put it in there. But again, that doesn't stop other people from doing it. So I don't think there's a way that you could specifically do that.
Mhm.
But yeah, I think it's just one of those, you got a knife, you got to try not to cut yourself kind of thing.
Right. So how are we doing with the time, by the way?
We got a couple more minutes. We have a few minutes. We can hang out
Okay.
for a little bit.
Okay. So let's. Um, Lost in the browser. Sorry. Where are we? Yeah. So here I want to show you one more thing.
Hmm.
Let's go to the AKS. I want to show you the metrics basically. So we have this container um, because we are running in AKS, and we also have those other metrics in there.
Hmm.
So let's look at that one just to make sure that. So there you go. So this is the metrics that you get directly from your AKS. So technically, when you relate all these things together, you can make more sense of what it all means, right? So now in this case, we have this nodes running. So I only probably have only one node to work with. And then I have like a lot more containers. You can actually see the containers that are working on here and get into the more details of it, like, what is the creation time and how much CPU limit, CPU requests, and other things are using. And over a period of time, you can kind of like take a look at it, like, how performance, how are things with performance, and based on situations like, okay, you may need more, maybe more nodes to kind of like scale up, and you can make those decisions and kind of configure the alerts and all kind of things, right? So I'm pretty sure there's a lot to be talked about here, but then there's enough documentation out there to just get to those information that you want quickly, right? So like, for example, like for this is a very fairly simple application, but we can kind of like build these dashboards out here and kind of look at like, okay, here's the raw APIs and the other sort of information that kind of built in to kind of like run this application in real time.
Got it.
All right, now let's look at the the feature manager, and the reason why I want to talk about that very quickly is, I mean, now that when you are having this whole world of distribution, you want to configure something. You don't want to keep the configurations in local. Instead, you want to work with something like a centralized configuration, so that no matter which part which comes up, and the services going up and down or things, it can actually go for centralized configuration and look for what information that it needs to work with, for example. And there is also feature manager as well, like, whenever you want to deploy something to production, but you want to enable a feature on a certain time or certain region or certain set of people, right? So then you can actually use something called as feature management, which actually depends on the configuration, on the centralized configuration, and then you can toggle those things. For example, in this case, I have this weather data. You can see this. I'm using the data which is actually going and hitting the real API, but in the real time, I can actually toggle this using this simple switch here, which is the static weather API. Once I toggle this, and if I just go and refresh this, now I'm using the static data back again. On live, I basically changed a running production application, and if I want to do some testing, kind of things, I can put all those things. And I did not write a code to do any sort of deployments and other kind of things for just to test this thing, right? So this is really, really handy feature. One of the patterns or key features that you can probably make use of in the distributed world is to have a centralized configuration, and you can use them like this, right? So this is what I showed earlier, where in this scenario where we had this feature manager that is enabled async, this is what it looks for, that information, right? And then configures, and you saw that the UI also was toggling, and that's because we have this nice uh, reads a component out there, which actually has this. So when the feature name feature is configured weather API, it puts all those select options, and then if it is the other one, it just puts in some static data. So you can see that how you can toggle these things in real time. Once you bake in this code and check in, run it in production, it's just going to be the configuration changes. And yeah, I wish we had more time to talk about these things, but then
But I'm such a big fan of the feature management stuff. And early on, I was one of those folks that was like, oh, why do we need this? I don't see what the point is. Because if I wanted to change the behavior, I used to do it with like the environment settings. So, in ASP.NET Core, you have, I think it's called iHost environment or iWebhost environment or something of that sort.
Yeah.
And then I would check and I would see, well, I would have, am I in production or am I in development? And then I used to have additional environments. Sometimes I do a tie environment or a containers environment or, whatever the case is, right? And I would feature toggle that way. But then, kind of like what you mentioned before, when you're in this world of distributed systems, now it's not just about like me and my single app. Now it's about like the collection, right? And things that we want to have across the board. And how do I reset all the services at the same time so that they're using the same feature or the same feature flag or the same feature toggle? Because features can span multiple services and not just one service. You know what I mean? And so no, I'm a big fan of feature management right now. I really love those ASP.NET Core components that you showed a little while ago. I think that just makes it even so much easier. And another thing too that I didn't realize, but maybe some folks that are watching may not have realized that as well. The feature management package, you don't need Azure for it, right? Like you can just run it locally and you can configure it with a file, or you can configure it with the feature management service that's in Azure. So again, you have options to pick and choose how you want to do these things and build your microservices.
Correct. And as you rightly said, feature manager is two different things. Like, feature manager just toggles it. Like it gives you those entire infrastructure in place to kind of like toggle the things. But that's when you put it into centralized configuration, that's when it makes more sense, because now you're not configuring it through the configs files anymore. You're configuring it at a central point. And then regardless of Kubernetes throwing your pods around and other things, the feature is active for any service. As you rightly said, it can be multiple services too, which will use the same feature.
Yeah, exactly. So what else you got for us, Nish?
So I think this is something which you'll hear for the first time on this show.
The breaking news? Is that, like, what do we get?
Yeah. So where do you learn all these things, right? Wouldn't it be nice to have some kind of page in which you can actually learn everything in one place? So now we have this brand new page called Cloud Native and Microservices. If you click on this, right?
And so this is on the .NET website. So if I go to the .NET website and I click on Learn, right?
Yeah, go down, and here it is, Cloud Native and Microservices.
Nice.
Click on this one. And then there's like a lot of other things like, microservices hands-on modules. Actually, you can click on this one. Let's see. So once you go inside this one, whatever I talked today, instrumenting a cloud-native ASP.NET Core microservices, start with this. And it talks about Checks, Serilog, and you're going to actually do a hands-on coding on this. And it is all going to be run behind the scenes inside the Azure Kubernetes services. So you don't have to come with any installation. Don't even come with a PC. Just come with an iPad.
With a browser.
Sit on a coffee table and just, you can execute this code. So you can do that.
That's awesome.
And and also feature flags. Like, I literally showed or lightning thing of feature flags, but I think
Right.
there's a lot more to that. So you can actually go and look at those information out here. So really great places to get started and have more information. So there are also architecture guidances, and there's like bunch of ebooks you can exactly, for example, like if you want to understand more about architecting cloud native apps, right, you can go here and say click on download PDF, and then there you go, there is a PDF. No information, no name, no email ID, and no contact information. Like, all that you need to do is just click on the download PDF, and then you have this really amazing book that you can read it at your
That's awesome.
convenience.
And every time I go to that architecture guidance page, there's just so many books, and there's
Yep.
so many books, and they're all for free. I don't have to put in my email address. I don't have to give you my phone number or my firstborn child. I could just download the ebook, and it's fantastic.
Yep.
So I think it's a great resource for people that maybe you want more detailed information about deploying things, or maybe you just want to get started. Maybe you want to learn about Dapper. Maybe you want to learn about Kubernetes or Docker or whatever the case is. Tons of great stuff, and it's all for free. And all you have to do is head over to the .NET website and click on that little learn item at the top of the menu, and then you'll be on your way.
Yep, that's perfect.
Awesome.
So we can take questions now, or
sure. We did have a couple of questions. I'm going to do a couple before we turn off. So this one's coming in from YouTube, and this person is asking, Nish, can you tell us if you have any suggestions about the API gateway structure? So I'm guessing, do you have thoughts about how it's used, how to use it? Maybe one of these ebooks talks about it as well, maybe.
Right. If you come here and search for eShop, eShop and containers, this is a reference sample. You click on this. This is the very popular sample on microservices implementation. And here we do have implementation of how to use API gateways. And also, while we talk about API gateways, there is also implementation like backend for front-end pattern, which is like if you have mobile applications, you have web applications, you want to have separate aggregation for each of it, you can actually implement those gateways and things like that. For eShop, actually, we used to use Ocelot for a very long time. We have used Ocelot as an API gateway, but there was a time when we had to move all the internal communication to gRPC. So all the service-to-service communications are on gRPC, which is mostly the aggregator. And Ocelot did not have that support at that time. And we looked at it and we said, like, okay, for now API gateway, we are not using any of the other API gateway features. So what we're going to do is we're going to use Envoy proxy, which does nice configurations for path redirections and other things. And we also had this service mesh implementation that was coming on top of it, which is using Linkerd. So because of that, we standardize on having Envoy proxy. It doesn't have a lot of API gateway implementations, but it definitely have good routings and other things. And the aggregators are basically written in the .NET code itself. So take a look at that, and it has more information on API gateways.
And I know we also have a reverse proxy, right? We have something called YARP. YARP's still pretty fresh, like it's still in development. But it'll be interesting to see if in some future version of what we're showing here, if we can see how YARP can plug into some of these architectures.
Yeah, I think we can replace that Envoy proxy and then put in YARP there, and I think it's actually focused on building, making higher performances for the Azure implementations and that kind of things.
Yeah.
So I think we would definitely use something like that when it's out.
Awesome. All right, let me scroll through. I believe we did have a few more questions. Let me see what folks are asking about. Got that one. Let's see.
Someone's asking about the browser. Please name name of the browser used. This one. This is Edge. This is.
Oh, you're using the vertical tabs in Edge. A lot of people don't really know about that.
This is so cool, especially if you have a large real estate in terms of monitors, it just makes it easier. And I'm just making it easier because I need to read. So the moment you go like this, I literally can't, like if you have more tabs, I'll only see these icons and I can't see what exactly that means. So
yeah, I think the usability of the side tabs helps. And I noticed I have less tabs open when I use the side tabs. For some reason, I feel like I need to close them. When they're at the top, I kind of just ignore them, but I don't know. Right. Maybe that's just my psychology, but that definitely happens for me.
Yeah, it's the same with me. Like if you have more than certain tabs, I feel like closing the entire browser and just coming back to.
Yeah, exactly. We got one question that came in earlier, and this was about the health checks UI that you showed earlier. Now, the person's asking, I'm curious if the dashboard for health checks can be customized. I'm guessing that means like if you could, update the user experience and, maybe probably brand it or, change the layout and things of that nature.
Yeah, I know for sure changing the branding is possible. Like you can just go and change the sitemin CSS and then make the look and feel of it, add your images and other things. But how much of the other customization, I am not very sure. Like, I mean, you can go to it's an open source project, so you go to the Health Checks UI project from Zabril, and you probably can see the code to see how much of customization you can do on that one.
All right. This person is asking, got a URL for that image and stuff? Image. I'm guessing he's talking about the eShop on containers one, the one that you're showing right now. So that one's on GitHub, right?
Yep. Yep. This is here, GitHub.net architecture. So that's the URL.
So github.com/.net architecture. So I'll make sure that folks in the chat get that really quickly. .NET architecture. And then it's just eShop on containers, right?
Correct. That's
okay. All right, pasting that in the chat right now.
We also have eShop on Dapper now. It's pretty cool. Like it actually shows how much of code that we actually, removed from eShop on containers when we moved to the Dapper.
Yeah, I'm sure it helps a lot.
Yeah.
All right, so I think that's about it. I think those are all the questions.
Okay.
So Nish, hey, thank you again. Every time you come on, you come with like some really great demos, and I really appreciate all the cool information. I know people are going to ask me where are the demos, where can they get your stuff.
Yeah.
So what should I tell them?
Yeah. So it's so this is I will add the readmes and things because I was in a hurry to just complete these demos. So
sure, that's fine.
So it's called the on.net-observability. So pretty much every time I do a show with you, like I'm probably going to have
my own repo. I appreciate that. I appreciate it.
Yeah, so it's all in here. You can actually run this locally with Tyrun, but I'm actually getting more. By the way, Sumit, one of my team members, he kind of like helped me with a lot of other stuffs in this, sure. And he's gonna I think he has an implementation on it for AKS one separately. We will add some more README stuffs on this so that you have more information on how to deploy this to Azure and kind of like do that entire log analytics and tracing and things like that.
Right, for sure. All right, well, hey, Nish, again, so I've shared that link with everyone. So you should have the links to the eShop on containers that's in the chat. You should have the links to Nish's demos. And again, I also want to remind everyone that tomorrow we are going to have that Let's Learn microservice event. I'll paste that in the chat again as well. So that's going to be tomorrow morning/afternoon, depending on what time zone that you're in. It'll be 8 a.m. Pacific time. So again, adjust that to your time zone. But they'll be talking about microservices. They'll be doing some Microsoft Learn hands-on workshops, and also Nish also created some content for that. So that'll be cool to kind of check out. But with that being said, I think it's a wrap, man. I think we can call it a day. Thank you all for joining us. And I know I called out a bunch of countries earlier, but I see everyone that's in here. I see folks from Mexico. I see everyone from Istanbul. We have folks here from Africa joining us. So again, just want to let you know, I see all y'all. I appreciate it. Thank you all for joining us. Make sure you join us next week because we'll be back. It won't be Microservice March, but it'll be something different. But make sure you come and check it out anyway. So thank you, everybody. Take care.
Thank you so much.